Hi, this is 10-1 in Advanced Algebra 2. Today we talk about sequences. We have arithmetic sequences and geometric sequences. Arithmetic sounds like the word arithmetic, or it looks like the word arithmetic. An arithmetic sequence is a sequence of numbers in which every term is found by adding a common difference to the preceding term. So the terms will be listed like this. They'll be like a sub n, where a stands for the arithmetic sequence and n stands for the term number. So for example, this says a sub 1, which really means the first term is 3. And this means the second term is 5, the third term is 7. So A's for arithmetic. And as you can see, the sequence goes 3, 5, 7, 9, 11. Well, from the first term to the second term, it went up by 2. From the second term to the third term, it went up by 2, and etc. It continues to go up by 2, and that's what the dot dot dot's all about. It's like that's just going to keep on happening. This sequence is going to happen arithmetically. The common difference in this particular red arithmetic sequence is 2. Well, over here we've got another arithmetic sequence, and this is went down by 5, and etc. So you can see the common difference in the blue arithmetic sequence is -5, right? You can add a -5. It's just like subtracting. And then, oh no, this is an arithmetic sequence. If we find the common difference, it's 1/2 minus 1/4, which is 1/4. And then this went up by 1/4, up by 1/4, up by 1/4. So to find the common difference, it's any two terms minus each other where you've got a bigger term minus a smaller term. So like the common difference would be like the second term in the sequence minus the first term in the sequence. Or you could do like the third term in the sequence minus the second term. Any two consecutive terms, if you find the difference from them, with the bigger term minus the smaller term. So you do the 100th term minus the 99th term if you really wanted to, and that would tell you the common difference. Okay, so here in arithmetic we have that already, my bad. This is what most books give for the explicit formula for an arithmetic sequence, where any term you want to, the nth term in the sequence equals the first term plus the quantity of n minus 1 times d, where d is your common difference and n is the term number. I don't like that formula. It's just complicated for a lot of people. It's the same thing as this. The nth term in the sequence will equal your common difference times n, where n is just a variable, plus the 0th term in the sequence. And I'll show you what I mean after we do a bit of an example here. So it says, find the next 4 terms in the arithmetic sequence. So here's what they're doing. They're telling us that it's an arithmetic sequence right here. What we need to do is find the common difference. Well, if the first term is 7 and the second term is 11, I'll take the second term minus the first term, and I'll get d equals 4. Right? 11 minus 7 is 4. Tell me that d equals 4. Don't just put a 4 up here. I want you to write that. Then you'll see again, if you do it here, 15 minus 11 is also 4. So the common difference in this arithmetic sequence is 4. That means every next term will go up by 4, since that's a positive 4. So we went 7 to 11, 11 to 15. If I just add 4 more to that, I'll get 19. Add 4 more to that, I'll get 23. Add 4 more to that, 27. And add 4 more to that, I will get 31. So this is really a sub 1 right here. This is a sub 2, the third term, the fourth term, the fifth term, the sixth term, and the seventh term in the sequence. So what they want us to do is graph the first 7 terms in the sequence. So as you can see here, I've already got it graphed, but you can do it. I just wanted to show my table of values here. When n was 1, the term in that arithmetic sequence turned out to be 7, right? Isn't the first term 7? So that's why I plotted the point 1, 7 right there, and you can plot that. Then the second term in the sequence was 11, so that's why I plotted 2, 11, right? Because this is your n values right here, and this is your a sub n. It's like the actual term in the sequence. So the third term in the sequence was 15. The fourth term was 19, and etc., etc., etc. we're just going to graph all of those. But you don't connect the dots together, because if you did, then that is like a continuous function. And arithmetic sequences are not continuous functions, because remember, down here n stands for the term number, and you can only have an integer for a term number. You can't have the 1.5 term or the 3.5 term or anything like that. So that's why you don't connect the dots together. You just say, oh, this is the first term, the second term, the third term, the fourth term. This will be a discrete graph because it's just made up of dots, right? If you connect the dots, that's a continuous graph. Hey, I'm going to do some just for fun problems. Let's write the explicit formula for this particular, even though the homework doesn't ask us to do this, let's do it just for fun. Explicit formula, I got to know two things. I got to know d, which we already know in this problem is 4, right? D equals 4. And I got to know the 0th term. Well, the 0th term is the term right before the first term. And if these are going up by 4, up by 4, up by 4, to go back and find the term right before it, I need to go down by 4. So the 0th term would be 7 minus 4, which is 3. So any term in this sequence that I want to will be 4 times the term number plus the 0th term, which we just figured out is 3. And you can see that's like in slope-intercept form. It's like that would be the y-intercept of 3 right there, and then the slope is 4, rise 4, run 1, rise 4, run 1, rise 4, run 1. So this is the explicit formula, meaning if I wanted to find the 37th term in the sequence, I would say a sub 37 equals 4 times 37 plus 3, and 4 times 37 is 148. So the 37th term is 148 plus 3. The 37th term is 151. Like, instead of having to figure that out, I have an explicit formula for this bad boy, which they're not asking you to do today, but we will do soon. Might as well do it right now. Find the next four terms in each arithmetic sequence. So they're telling us in these problems that it's an arithmetic sequence, then graph it. So what we need first is the common difference, what d equals. To figure that out, you take the second term minus the first term. 111 minus 106. That would be 5. So since the common difference is a positive 5, aren't these increasing, right? Going up by 5, up by 5, up by 5. Then we'll fill this out. 116 plus 5 is 121. Add 5 to that, you can get 126. Add 5 to that, and add 5 to that. Now we just plot those points. So this is the first term in the sequence. So 1, 2, 3, 4, 5, 6, 7. Remember, these are your term numbers right here. The first term is 106. The second term is 111. We're just kind of rough guessing, you know. This is going up by 25. You can't be super accurate with it. Then 116, and then 121. 126, and then you can just kind of follow your path right here, because you know it's a constant rate of change. It's always going up by 5, so this is a linear situation. You just don't connect the dots because it doesn't make sense to have a 1.5 term. These numbers down here are the term number, so you can only have the first term, the second term, the third term, the fourth term. Now you can have a 0th term and a negative first term. They have to be integers. They just take a little getting used to. So no non-integer n values. So let's do this one. It's arithmetic because they told me so. So I got to take negative 31 minus a minus 28. So like minus a minus becomes a plus, and that means my d value is negative 3. So that means that these numbers are going down by 3. So let's fill out these blanks. Let's go down by 3. I'll help you with the first one, negative 34. If you subtract 3 from it, will give you negative 37. And then negative 40, negative 43, negative 46. Those were pretty easy to mentally compute. Now we'll graph them. It's at 1, negative 28. So remember, negative 28 is above negative 30. Then negative 31, negative 34, negative 37, negative 40, so I kind of messed that up a little bit, negative 43, should be nice, neat, and straight. You just don't want to connect the dots together. One more that I'll do with you here, maybe two more that I'll do with you here. So I need to find the common difference. They tell me in the instructions it's arithmetic, so take 194 minus 207. And this might be a nice little calculator problem. So 194 minus 207, my common difference equals negative 13. So now, the previous ones were so easy, I mentally computed them. Now I need to just go down by 13 to fill out the rest of these values. So I got the first term, second term, third term already. I need to take 181 and subtract 13 away from it, and I get 168. And then all I have to do, since I have this guy in here, just hit minus 13 again, and it'll do my previous answer, minus 13, which is 155. And now the previous entry in my calculator said, please take the previous answer minus 13. So it's already sitting there with that previous answer. If I just hit it again, it'll take that 155 minus 13 and give me the 142. So all I did was hit the equal sign. Once my calculator was programmed to say previous answer minus 13, so 142. Then if I just hit equals again, it'll do it for me and hit 129. And then I'll graph those points. You can pause the video and get those graphed. And it should be pretty linear. I mean, I know it's just a little bit of guessing game right there, but pretty simple. This one, extremely simple to graph. So remember, we've got to take the second term. They told me it was arithmetic minus the first term, so minus a minus 30 is really plus 30. D equals 10, baby. The common difference is these are going up by 10. So this would become a 0, this would become a 10, a 20, and a 30. Real simple to graph also. 1, negative 30, then up to negative 20, then up to negative 10, 0, nice and linear. Oh, we forgot to write the old explicit formula. I wanted to do that. Well, let's have fun with that. So, here's that generic formula. My bad. Generic formula. It's the nth term in the sequence. Any term you want to will equal your common difference times n plus the 0th term. Well, the nth term in the sequence will equal my common difference is 10. And then the 0th term, if these are going up by 10, up by 10, up by 10, up by 10, to find the 0th term, I'll go down by 10, which would make that a negative 40. Let's go back, and this is the explicit formula for this particular arithmetic sequence. Let's go back and do that to this guy. A sub n equals the common difference times n plus the 0th term. Well, any term in the sequence will equal that common difference of negative 13. And then the 0th term, if this is going down by 13, I need to go up by 13, and that would get me to 220 right there. So you can see that that's like your y-intercept right there of 220. At the 0th term, that'd be 220. And we'll do that for this guy also. A sub n equals your common difference times n plus the 0th term. Well, a sub n equaled the common difference was negative shui. And then the 0th term, if these are going down by 3, then this probably has to go up by 3. And negative 28 plus 3 is negative 25. So you can see that that's where that y-intercept would be. Awesome! So, two more here for you on the arithmetic. Why don't you pause the video, get those done for me, please. Do both of them. And hopefully on number 5 you realize that the common difference was negative 6, and here's the terms. And on number 6 the common difference was a positive 26. You could have used your calculator to keep on figuring those out. Just for fun, let's start with the formula here. Plus the 0th term. Any term you want in the sequence is the common difference, which is negative 6, times n. This is not a subscript now. That's up in the same level. That's a real base right there. Plus the 0th term. Well, these are going down by 6. I need to go up by 6. And 13 plus 6 is 19. And over here, a sub n equals d times n plus the 0th term. A sub n will equal, the common difference is 26 times n, and I need to subtract 26 from 151 since these are going up by 26, so 151 minus 26, boom, is 125, is that y-intercept or your starting term right there. Sweet. Those were arithmetic sequences. Now, a geometric sequence is it got a common multiplier, or we call it a common ratio right here. So as you can see here, we use a G instead of an A for geometric. The geometric sequence's first term is 3, the second term is 6, the third term is 12, the fourth term is 24. You can see that I had a common multiplier of 2. This got times 2. Then I took the second term and I took it times 2. And this got times 2. There's a common multiplier. Here, again, this got, a lot of people would say divided by 3, on this dude, but it's really times 1/3. And then from here it got times 1/3. And then from here it got times 1/3. So there's a common ratio. How do you find the common ratio? Well, you do it like this. You take any previous term, I shouldn't say any term in front of a previous term. So the ratio would be like the second term. Come on, pen. Sorry. The second term divided by the first term, right? And if you take 10 divided by 3, 10 divided by 30, you'd get 1/3. If you do the third term divided by the second term, you'd still get that common ratio. If you took the fourth term divided by the third term, you'd get that common ratio, right? It's even easier to see over here. Fourth term divided by third term, 24 divided by 12, 2. 12 divided by 6, 2. 6 divided by 3, 2. So it's always the term in front divided by the guy right behind him. So, and then here's that explicit formula for you. The any term in a geometric sequence will equal the first term in that geometric times the common ratio to the n minus 1 power. That's how we'll write it. So, find the next 3 terms in the geometric sequence. They straight up tell me that it's a geometric sequence. So to find the common ratio first, I need to divide the second term divided by the first term. So the ratio equals 6/2, which is really 3. Right? So the common ratio is 3. So that means that these are getting 3 times larger. 3 times larger. So to find the fourth term in this sequence, since the third term is 18, I'll take him times 3. Boom, 54. Then I'll take that times 3. It'll give me that previous answer times 3 of 162. And then I'll just hit enter again, and it'll give me that next term, 486. Interesting, when we graph this, make her bigger. 1, 2. Well, holy cow, this is at 75 right here. So 1, 2 is going to be like way down yonder. 2, 6, pretty much same spot. 318, well, we're getting a little larger there. 454, hey, we're making some headway, but we're still not even past that first tick of 75. Then 5, 162. All right, I'll just kind of rough guess that to be about right there. And then 6, 486. Boom, right there. We don't connect the dots either, but can you see that this is like that exponential growth? If we write the generic sequence for this, the any term in the geometric will be the first term times that common ratio to the n minus 1 power. Well, g sub n will be, the first term is 2 times my common ratio of 3 to the n minus 1 power. You can see that this is an exponential growth type situation because that base is bigger than 1 right here. Right? It's got translated 1 unit left, and it got vertically stretched by a factor of 2. All kinds of cool stuff that we already know about this graph. We just don't connect the dots together because these are term numbers in our domain right now. So, got our graph. Over here, find the next 3 terms in the geometric sequence. They already told me it was geometric. So what I got to do is take the second term divided by the first term. So my ratio will equal, remember we're not using a d here because this isn't a difference, it's a ratio. The second term is 1/4, and I got to divide that by 1/16. Well, that's not cool. You can't divide fractions like that. It's just not proper. So keep your numerator of 1/4 and now multiply by the reciprocal of this brother over 1, sorry. And then 16/4 is what you get, which is really the number 4. So my common ratio equals 4. that means every term should be getting 4 times bigger. So if this is a 1, take it times 4. Then take 4 times 4 and get 16. Then take 16 times 4 and get 64. So there's our numbers. We'll plot them. So 1/16, holy cow, that's a 10. 1/16, let's use red. 1/16 is basically right there. 1/4, not much higher at all. 1, very, very tiny. 4, about halfway. 16, hey, hey, making some headway. A little more than half. 64, way up yonder. Again, this is an exponential growth because our rate was more than 1. That's our base right there. So the generic formula, g sub n, will equal the first term times the rate common ratio to the n minus 1 power. So this would be the nth term in the sequence equals 1/16 times the common ratio of 4 to the n minus 1 power. Remember, it's still exponential growth because 4 is the base. 1/16 is just like a coefficient. You can't multiply the 4 and the 1/16 together because of the order of operations. You got an exponent on that guy, so this is an exponential growth situation. You got that asymptote that this thing is approaching but never touches. La 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 la. Alright, do the last one for me. Find the common ratio by dividing the second term by the first term. So we'll do it together. I'll just give you time here. Second term divided by the first term. We always want to reduce the fraction. We don't want decimals at all. Decimals are no good for us. 4/20 reduces to 1/5. No decimals, my friends. The common ratio is 1/5. That means I need to multiply every term times 1/5. Well, that's so much easier than you think because I got to take 4/5 times 1/5. Well, guys, since there's a 1 in the numerator is always going to stay whatever it was originally right here. And now we're just taking the denominator times 5. Wouldn't that be 4/25? If we take him times 1/5 again, numerator gets times 1, so you still get a 4. Denominator gets times 5, and 25 times 5 is 125. Then I got to take him times 1/5, so numerator times 1 is 4, denominator times 5. Well, you can punch that in if you need to, but it's 625. And now let's plot the points. 120, because the first term is 20, so bada bing. The second term is 4. Holy drop-offs, Batman. Then we go to 4/5. That's less than 1, so that's way down, meow. And then 4 1/25, well, that's even smaller because the denominator is bigger, and then this guy's even smaller. This kind of looks like an exponential decay. Well, let's see. The nth term of a geometric sequence will equal the first term times the ratio to the n minus 1 power. The nth term equals, well, our first term is 20 times my ratio, which was 1/5, make sure you put them in parentheses, to the n minus 1 power. Isn't that base right there between 0 and 1? So that's an exponential decay. Yay! And then number 9 you can try on your own. Get a common ratio, find the next 3 terms, and plot. Ooh, interesting. It's kind of got that old, looks like it got reflected over the x-axis kind of look to it, because if we write the generic formula for an explicit geometric sequence, n minus 1, the nth term will be the first term, which is a negative 24, times the ratio, which is 1/2, to the n minus 1 power. Well, purple note card me. Did it get reflected over the x-axis? Yes. Translation: 1 unit to the right, 0 units up, and then etc. This is exponential decay because this thing is between 0 and 1. It's like it all just makes perfect sense, like we've been doing it all year long. Amazing. Finally, determine whether this is an arithmetic sequence, a geometric sequence, or neither. Well, if it's arithmetic, right, see, they told us in the previous problems what kind of sequence it was. Now we got to figure it out for ourselves. If it was arithmetic, it'll have a common difference every single time. It's got to go up or down by the same amount. If it's geometric, then it's got a common ratio. It's got to be multiplied by the same common number every time. If it's neither of those, if it's not not this and it's not that, then the answer is neither, and we'll explain. So, first thing I like to do is just kind of look at it and see what happens. It's like, boy, this number got bigger, and then it got way bigger, so I can see that it's already not arithmetic, but I'll just show you in the calculator why it's not arithmetic. If you take the second term minus the first term, 456 minus 57, you get a common difference of 399. Well, did the from the first term to the second term to the third term to the fourth term, from the third term to the second term, did it also go up by 399? Well, you can tell that there's no way that it went up by 399. 3684 minus 456. I did not get 399 back, so it is not arithmetic. When it comes to geometric, you got to get a common ratio. Well, 456 divided by 57. I didn't hit the divide by. Come on, buddy. You get a ratio of 8. Well, did it get go down by, or multiply by 8 again? 3, 6, 8, 4 divided by 8, excuse me, divided by the previous term, which is 456. Let's see if I get 8 back. I want to take the third term divided by the second term, see if I get 8 again. Ooh, not quite. Close, but no cigar. Didn't happen. Be careful with this. Some people think that the next term is like 29, and then the term after that's 184. This is 29,184. You see how they tried to be nice and separate with semicolons here because this number has a comma in it. But this was not arithmetic because we didn't get a common difference, and it's not geometric. So what do we want to put? It was a neither because there was no common difference nor a common ratio. That's how we knew that. There was no common difference nor common ratio. The next one, it looks like it would probably be arithmetic if I was to guess, and it looks like they're going down by a similar amount. So let's figure it out. Let's take the second term. Let me slide over. Feel that slide? That's nice. Second term of negative 37 minus the first term, which is negative 49. You could have put a plus there if you wanted to, but I got a common difference of 12. That doesn't mean anything, right? So I put a 12 there. I want you to put a 12 there also, like on your paper. You have to check to see if you keep getting that 12 back. So negative 25 minus a minus 37, which is plus 37. Did you get a common difference of 12 again? Yes. That's still not good enough. It has to happen the next time, so you just got to keep checking these. Plus 25, because it's minus a minus. Hey, 12. Yay! So this is an arithmetic sequence because we kept getting a common difference of 12. Arithmetic because there was a common difference of 12. So on the next dude, kind of looks like it would be an arithmetic sequence situation. If you take 9 minus 4, you'd get 5. If you take 16 minus 9, though, you get 7. So no good right there. Okay. What if it's geometric? Well, let's take 9 divided by 4, and you'd get 9 fourths. Right? Then if you take 16 divided by 9, you get 16 ninths, and these are not the same ratio. You can double check in your calculator. 9 divided by 4 is that. 16 divided by 9 is that. And that's not the common ratio. There was not a common difference, so this is a neither also, because there's no common difference or common ratio. Hey, those are your perfect squares. This is a sequence. You know, I mean, like all of these, they are sequences. Like, don't get them wrong. Don't get me wrong. It's just not an arithmetic sequence, and it's not a geometric sequence. But do you see that there's a sequence because it's just these are our perfect squares right here. So interesting. And then finally, to me, it looks like maybe this is geometric. You know, it looks kind of like this is half as much. So let's see if it really was. Let's take 412, the second term, divided by the first term of 824. Boom, I got 0.5, so you can write 1/2 down. And then see if it happened again. 206 divided by 412. Half 103 divided by 206. Boom. I kept getting a half back. So this is geometric because there's a common ratio of 1/2, baby. Awesome. Your homework is to do the 10-1 worksheet. Let us know if you have any questions. Have a good one.